Texas has impounded more surface acres of water than any other state. These man-made lakes were created by a system of dams which has brought a source of electrical power, flood control, and irrigation benefiting all Texas. Our growing cities and industries need stable water supplies, so new lakes are constantly being built. These large water impoundments provide an added benefit for outdoor-minded Texans. Wide open spaces for all types of water recreation. One of the most popular forms of water recreation is fishing. The Texas Parks and Wildlife Department is the state agency responsible for the management of the fishery resources of Texas. Surveys and records compiled by the department show that the vast expanse of open water found in our large reservoirs is inhabited mainly by rough and forage fish. These fish grow large, unmolested to any great extent by our native game fish, and unwanted by most fishermen. Fishermen know that the best fishing is usually found in brush and shallow water. Why our native game fish prefer this type of habitat is explained in their biology. Until recent years, there were only a few lakes in Texas. Our native game fish are well adapted to stream, river, and pond environments. Our fish have specific demands for cover and food. These demands, especially cover, are not found in the open water expanses of the big lakes. Some lakes start as fishing hotspots because of favorable environmental conditions. They reach a peak for good fishing in 3 to 5 years while the game fish species are dominant. Then something happens. After the peak is reached, the lake almost inevitably begins to decline as a fish producer. This decline is the result of many causes and factors. Fish and reservoir management is a new science, and not simple. A great deal of basic research is being done to gather more information, not speculation, about fish and their habits. Biologists have learned that when a lake is on the decline, additional stocking of native game fish by itself will not provide good fishing. As an example of the way information is gathered, tiny radio transmitters are inserted into flathead catfish at Lake Medina. The catfish is captured, tranquilized, weighed, examined, and measured. A small incision is made. The transmitter is inserted. Then the incision is sewn up. A sulfa drug is applied to prevent infection. Then the fish is walked to revive it. The fish is released and never knows that department biologists are using direction finders to chart his hourly and daily movements. We have learned that a flathead catfish travels very little from his home area. We've also gathered data on his diet, which indicates he is one of the best predator fish available for our lakes. Predation is essential in the complicated food cycle, which provides the wide variety of fish valued by man for sport and for eating. In simple terms, the food cycle constantly in motion in our lakes begins with plant and animal life. Tiny one-celled organisms. A growing, drifting community for the most part, undetectable to the human eye. Forage and rough fish feed primarily on plants. Because of their position on the food cycle, their simple feeding patterns, and because of their reproductive capacities, forage and rough fish have amazing survival ability and the potential to dominate a lake. Some rough fish, like bowfin and gar, are also included in the predator group. Many invertebrates, such as insects and larvae, also feed on the plankton. Small fish feed on plankton, invertebrates, and smaller fish. Large game or predator fish feed on smaller fish and invertebrates. It would seem that game fish are in the best survival position, but because of their dependence on the complete food cycle, the large game fish are the most vulnerable. The ideal proportion of game fish to other fish species is beneficial to a lake as well as the fishermen. When a lake becomes overcrowded, the food cycle is interrupted, and all of its inhabitants feel the change. When this happens, something must be done. There was an overpopulation of rough fish in Lake Lyndon B. Johnson. When the lake was lowered to construct a steam generating plant, the Parks and Wildlife Department decided to take advantage of the decreased area to bring the rough fish population under control. They used rotenone, a chemical which, when added to water, causes fish to suffocate. Beginning early in the morning, the rotenone is sprayed on the water. Sometime after spraying, the fish come to the surface. Many people came to the fish kill in hopes of taking home a large number of fish. Only a few game fish were dipped out of the lake. Rough fish were carried off by the tons. Department biologists learned several years ago that rotenone is not the complete solution for the overpopulation of rough fish. It is expensive and attacks only the symptoms, not the cause. Restocking of bass and catfish must be done immediately before the rough fish can return in increased numbers. Before the rotenone treatments, 300 large catfish had been netted out of the lake. During the treatment, they were held at a hatchery. The final phase of the restocking program was completed when the big cats were returned to Lake LBJ. To provide good fishing in the unused open portions of our lakes, we're experimenting with other species. Our most successful programs at this time are the importations of fish not native to Texas waters. For example, the muskie. And the friendly northern pike. Hopefully, they'll utilize this open water expanse and act as a natural control on the undesirable fish, but not compete with native game fish. One of the most promising imports is the walleye, a deep water species from the north, famed for good sport and excellent eating. The walleye is established in several Texas lakes. At Lake Meredith, north of Amarillo, they're not only thriving, but also reproducing. Biologists are utilizing this strong population to collect large numbers of brood fish for stocking other lakes. Traps are used to capture the fish. Males and females are separated. Eggs are taken from the females. Milk is taken from the males. Lake water and clay are added to the eggs. The delicate eggs and milk are mixed by stirring with a soft feather for fertilization. The fertilized eggs are then immersed to harden them. The fish are tagged for future identification and then released. After hardening, the eggs are carefully prepared for transport to the hatchery. At the hatchery, the eggs are poured into the hatching jars. The flow of water in each individual jar is adjusted to keep the eggs moving. The entire process is carefully monitored. The little fish will hatch within a period of 4 to 14 days, depending on variations in water temperature. As the fish hatch in the jars, they travel through an overflow valve to collection tanks. The next step is to transfer the fry to holding troughs. They'll remain in the troughs from 3 to 5 days. And during this period, the fry live on the yolk sac. When they start to swim vigorously, they are transferred to the rearing ponds. The rearing ponds have been prepared for the fry. First, they're plowed. Later, when the ponds are filled, the water is filtered to ensure that it is free of other fish and predaceous insects. Then the pond is fertilized to produce an abundance of plankton for the walleye to eat. Only then are the fry placed in the ponds. The fry will remain in the ponds until they're ready for a fish diet. At that point, they must be moved to the lakes. Walleye do not like to be crowded, so no time should be lost in transportation. They're taken in large fish trucks. These walleye are strong, healthy little fish with a good chance of survival. The fry are released in locations suitable for their growth and development. Walleye spend most of their time in deep, open water. Fishing for walleye is different from bass or crappie fishing. The successful angler fishes his lures deep and slow. Another good prospect for our reservoirs is the redfish, the famed bull red. This large saltwater fighter has shown amazing growth potential in fresh water. A group of our fisheries people went to North Carolina to gain experience in techniques and to gather brood stock. To capture the big reds, it's necessary to locate a large school. Biologists and commercial fishermen with nets go out in boats searching for the redfish. An airplane is used to help spot the schools. But as every fisherman knows, the redfish is elusive. A large school is sighted. The boats and nets encircle the thrashing reds. After the fish are trapped inside the nets, improvised methods are used to get brood fish into the boats. They're then rushed to the big boats, placed in tubs, and tranquilized. The tranquilized fish are taken to holding tanks and walked like precious babies. But they didn't make it through the night. Discoveries were made about the physiological reactions of the redfish under stress. Methods are being worked out to prevent excessive strain in the future. The department is having success in capturing redfish fry that were spawned in the wild. They're being fed on brine shrimp. Biologists have had some success spawning redfish in captivity. The Parks and Wildlife Department is hopeful that in the not-too-distant future, we'll have a large redfish hatching and stocking program. One of the most exciting prospects at this time is the striped bass. It will grow to a large size and has a good reputation as a predator. One of the big advantages of the striper is its tendency to feed in schools. Even young stripers feed and work together. In large open waters, predators must school. While a few of our native game fish, such as the white bass, feed in schools, even when mature, they're too small to handle the large, rough fish, like the shad, which the stripers feed on. In the eastern seaboard states, striper broodfish can be secured. The Texas Parks and Wildlife Department went to Maryland, where fisheries people from several states cooperated in a joint effort to obtain eggs from spawning stripers. Mature fish were bought from local commercial fishermen through cooperation with the Maryland Fish and Wildlife Administration. Eggs and milk were stripped from adult stripers. The fertilized eggs were placed in hatching tubs, which provided a gentle, circular current to keep them moving. When the embryos consumed their egg sacs and began to swim, they were loaded into plastic bags. Oxygen was added. The bags were placed into containers. And the fry were sent on their airplane trip to Texas. To experiment with larger stripers, 13 sub-adult fish were obtained and transported to Texas in a large fish hauling truck. In the meantime, the airplane with the fry arrived in Texas. The fry were put through delicate acclimation procedures to avoid shock from changing water and temperatures. The striped bass normally lives in salt water, but spawns in freshwater streams. The best condition for the hatching of striper eggs is about 50 miles of flowing tributary water. But it is predicted they can reproduce under less desirable conditions. the striped bass is an excellent introduction to our freshwater lakes. There are still many unanswered questions about fish and reservoir management, but the Texas Parks and Wildlife Department is working on them for both exciting new species of fish, as well as the popular old favorites. These projects are funded through the sale of hunting and fishing licenses and taxes paid on sporting goods. They benefit not only the fishermen, but also the economy of the state.